In this video, we're going to look at how to use for loops to output tables of calculated values based on the loop variable. So in this video, we're going to see that precisely that. You can make a calculation and print out a series of values based on a loop variable. We're going to look at how to produce output in columns, and especially how to use column headers before the loop to avoid redundancy and make your table easier to read. And we're going to take a quick look at output formatting to control more precisely how numbers appear. Starting here with a file that just prints some messages and sets up a scanner. Let's compile that and see what's going on. All right, so this is the problem. We want to print a table of values, inches to centimeters, with inches going from 0 to 30 inches in 6-inch increments. Right, so this is a typical for loop problem to calculate a value based on a series of values. Right, so the inches in this case will be the loop variable. And we can name the variable anything we want. So I'm just going to call it inches, starting at 0 to 30, and we'll assume here that we mean inclusive of 30, and going up by 6 each time. And till you get used to entering these compound statements, you may want to compile as soon as you put in the braces, just to check that you haven't made a mistake in the header. Right, so it's not going to do anything yet because we don't have any output in the table. Let's just output the inches and build this a little bit at a time. And you know what? Let's put the inches, let's put the value before the word inches the way we usually say it. So we usually say some value of inches followed by the word inches. Okay, so we've got a good start now. We've got inches going. We've got this part. We've got inches going from 0 to 30 in 6-inch increments. Now we have to calculate the equivalent in centimeters, right? So I want to look up. Okay, so we look up on the web and we find that 1 inch is 2.54 centimeters. So we set up some variables for this. That's plainly a double, and I'll call that the centimeter rate, 2.54 inches. All right, so now notice I'm doing this before I start the loop because it only needs to happen once. All right, statements that don't need to be repeated should not be inside the loop. All right, so within the loop, I have to calculate the equivalent centimeters, so I'll make another variable here called centimeters and multiply the loop variable times the conversion factor, and we add it to the print statement. We'll say so many inches is centimeters. Okay, and the line gets a little long there. All right, for very long lines, output lines especially, you can split them into 2 lines like that. So let's recompile. All right, and there we are. All right, so 0 inches is 0 centimeters, clearly. 6 inches is 15.24, 12, 18, 25, and so forth. All right, so this is the basic table, but it's rather wordy. Right? It's rather wordy. All this inches is centimeters, and it ends up being very redundant. So we'd like to have columns, just the word inches and the word centimeters once before the numbers start, and then we don't have to. We'll just label them before we start the loop, as in headers. So again, we only want to print the column headers once, so we do it before the loop starts. and we'll just print the word inches and some spaces, and then the word centimeters. All right, and now we don't have to say all this in here. We're just going to say inches, maybe separated by some spaces, and then centimeters. We may have to adjust the number of spaces in here after we see what it looks like. So we'll recompile, execute again. Okay, and we need to push the centimeters over more. All right, so the inches are all coming out right on the left. Centimeters are too close in. We can use a tab character to make some adjustments there. Now that's counts as a string literal. All right, so put it in double quotes. So \T, and then we'll try another one here. \T, recompile, re-execute, and that looks a little better. Maybe now inches isn't far over enough, so we do something like that. Okay, so that's roughly over the columns, but we notice that there's a couple of things wrong here, right? The numbers are lined up on the left in both columns, right? And the decimal points are not aligned, and there's inconsistent numbers of decimal points. All right, so when you have something like this and you're trying to get columns of numbers to line up, there's another way to print, another print method that's available called printf for formatted printing. Right, that looks like this. You just printf, and then format string, which lays out the whole line. All right, so I'm going to have a tab, and then wherever you get to where you want to put in a number, you put in a conversion spec. For integers, it's %d, then another tab, and then for floating point numbers, it's %f, and then you have to put in a \n to end the line, and then you list your variables: inches, centimeters. Okay, so I'm going to leave both in there, and I'm going to comment this one out so we can see what the formatting looks like. And lines up a little bit better. We see it added numbers of decimal up to 6 decimal places to the floating point values. They're still not quite lined up right, though. And what you can do is between the % and the conversion spec, you can put a number for how many spaces you want that output to take up. So if I want my inches to line up in 2 columns, 2 spaces, I can put a %2d. For floating point numbers, I can say the same thing. Now, I don't want to show all those zeros. Maybe I only want to show 2 decimal places. Okay, well that's 5 spaces altogether, because I have 2 digits to the left, the decimal point itself, and 2 digits remaining. So I have 5 digits altogether. And then you can use a period and a number like so to say how many spaces after the decimal place I want. So this is saying 5 total places with 2 places after the decimal point for a floating point value. And there you go. That looks a little cleaner. And we could move the inches over a little bit. And there you go. There's the inches to centimeters table. I'm going to make one more change to this. Right now, it's not really the best style to have literal values embedded in your statements like this. It's much cleaner to tease those out into separate variables so that you can more easily modify them. So I'm going to make three integer variables here. I'm going to call it the start and make that equal to 0. The bound, make that equal to 30. And the step is equal to 6. All right, now I'm going to replace these in here so that my description fits what's actually happening. That line's getting a little long, so I'm going to interrupt it. And then we're going to use the variables in the loop header. All right, so I made these changes, and just to improve the efficiency of the program, should not change the behavior, and it doesn't. But I can much more easily now make a different table. Suppose I want to skip 0 because I don't need 0. 0 inches is obviously going to be 0 centimeters. Maybe I want to go to 50. Let's say 60. And I want to count by 12 inches at a time. Right, so 6 inches is 15, 18 inches, 30 inches, and so forth. So it makes the program a little more flexible to change. We notice now that the centimeters don't line up anymore because they went into 3 digits. All right, so I need to add another place to my format specifier here for the centimeters. Make that line up again. And there we are. So this is the first time I'm bringing this out in the video. There'll be a separate video that goes into more detail about some of the other options and ways to use printf.